Okay, so now moving on into 3.3, which is looking at some applications of our synthetic division here. Particularly the first few problems in this section deal with using the factor theorem. There are two ways that you can do this problem. I'm actually going to kind of do two of the problems from the book simultaneously, number 5 and number 7. So number 5 asks whether, actually, let me pause this for a moment. Okay, didn't seem to make sense to make you guys sit and watch me while I write all this out. Okay, so what the factor theorem says is if this particular term is a 0 of this, then f of k, where k comes from, so k is the constant involved right here. So if f of k is equal to 0, then this term here is a 0 of that polynomial. So what kind of throws students is that you're really just looking at the k. So this has to be a minus sign in order for this to work. If it's a plus sign, you have to kind of finagle it a little bit so that you can figure out what k will be in order to make that a minus sign. So again, and the reason I'm doing these two problems simultaneously because clearly this one we've got a negative, this one we've got a positive. If it's a negative, then your k is just 1 in this case. Your k is just whatever this constant is. It is not negative 1, it is just 1. So for this one, we've got a plus sign. So we have to make this into a subtraction statement. Well, x plus 1 is the same as x minus negative 1, right? Because those two negatives will cancel out each other out and become a positive. So the k for this one will be negative 1. So it's essentially the opposite. If that says it's a negative, then your k is positive. If this is positive, then the k is negative. It's just whatever that number is and then the sign. So the book illustrates how to do this using long division, but we just did that in the last chapter. And I think it's sort of pointless because this method is a lot quicker if you can use it. So if they give you, in other words, if they give you the term that you need in order to do it, which in this case they do. So what we're going to do is that we're going to plug in this 1, whatever we figured out k to be, in for x, for every term in this polynomial, and see if our answer comes out to be 1. So for number 5, we're doing f of 1, and we want to see if this is going to equal 0. So I'm going to do 1 cubed minus 5 times 1 squared plus 3 times 1 plus 1. Okay, and again, by order of operations, we should do exponents first. So we've got 1 cubed, which is of course 1, and 1 squared, which is of course essentially just 1. All right, then we're going to do our multiplication. So 5 times 1 is 5, 3 times 1 is 3, and then plus 1. And now I just have to work out the problem. So 1 minus 5 is negative 4, plus 3 is negative 1, plus 1 is 0. So this one, for number 5, x minus 1, this one is a 0. And then we're going to repeat, I'm going to repeat the process for number 7. So I'm going to plug in negative 1 in for x in every one of these terms. Now again, since this is negative, make sure that you use parentheses so that you don't accidentally make things negative that should be positive. So to illustrate, for this one, we're doing f of negative 1. So that's going to be 2 times, this is where I'm using my parentheses, negative 1 to the 4th. Plus 5 times negative 1 to the 3rd, minus 8 times negative 1, and I'm going to run out of room, squared, unless I, haha, all right, and then plus 3 times negative 1, and then plus 13. Okay, so now again I'm going to work out all of my exponents here. Negative 1 to the fourth is negative 1 times negative 1 times negative 1 times negative 1. So for every two negative signs, they cancel each other out, become a positive. So the answer to this is positive 1. So we've got 2 times positive 1 here. Negative 1 times negative 1 times negative 1. Well, that's two negatives that get canceled out and become a positive, and then an additional negative. So that's going to be negative. So 5 times negative 1. Then we've got negative 8 times negative 1 squared. Oh, actually don't worry about that negative 8 for now. So negative 1 squared is positive 1. So we've got still our minus 8 out here times 1. And then we've got 3 times negative 1, or just since we've got, actually, so now we're at the point where we've figured out all of our exponents. So let's really follow order of operations correctly here. So now I'm going to do all of my multiplication in here. So I've got 2 times 1, which is 2, plus 5 times negative 1, which is negative 5, 8 times 1, which is negative 8, 3 times negative 1, which is, again, you can either do plus a negative or just make that a minus sign, and then plus 13. So now I just need to do my addition and subtraction from left to right. So 2 plus negative 5, well, that gives us negative 3. Negative 3 minus 8, well, that gives us negative 11. Negative 11 minus 3, well, that gives us negative 14 plus our 13, last term here, well, that equals negative 1, which is not 0, and that's the requirement. This has to work out to be 0 exactly, no ifs, ands, or buts. If it doesn't, then this term that we started with here, that is not a 0. Okay, and again, you are welcome to do this, figure out these problems by long division. If you get a remainder, then it is not a 0. If you don't, then it is a 0. It's totally up to you. I just find that this method works a little bit faster. Please let me know if you have questions.